Hi, welcome to the 5th Algebra tutorial. Today's tutorial is titled Dealing with Fractions. In terms of what I need you to know to progress with this tutorial, you need to have gone through the first 4 tutorials titled Basic Algebra, Factorization, Quadratic Equations, and Simultaneous Equations. You also need to be fairly familiar with your grade 10 work. So far, in your schooling career, you would have encountered fractions. In grade 9 and 10, you would have encountered variables in a fraction, i.e. x and y being in a fraction form. Now we are going to take it one step further, and we are going to put fractions with variables into an equation form, and then we are going to solve for the variables or simplify. We will begin by going through 4 basic rules we can use when working with fractions. I'll then move on to an illustrated example, and you can see how the rules are applied before trying some of your own. Rule 1. Get each side of the equation over a single denominator. Rule 2. State restrictions, if any. 3. Multiply out the denominators. 4. Solve as you would a normal equation. Example: 4x over x plus 2 is equals to 1 over 3 plus 2 over x. Solve for x. I'm going to start off by leaving the left-hand side 4x over x plus 2. The reason I'm going to do that is because the left-hand side has only got one denominator of x plus 2. The right-hand side, I've got two denominators. The one is 3 and the other one is x. I'm going to combine these to form 3x as my common denominator. That means my numerator will read x plus 6. Why? Because it's 1 times x and 2 times 3. I had to do that to the two numerators because I got my denominator common. That means that it reads 4x over x plus 2 is equals to x plus 6 over 3x. That's rule 1. We got each side over a single denominator. Rule 2. Let us look at the restrictions. Remember, a restriction means that it is something that the equation cannot equal or cannot be. Anything divided by 0 is undefined. That means that both our denominators cannot equal 0. That means that x plus 2 cannot equal 0, i.e. x cannot equal negative 2, and 3x cannot equal 0, which means that x cannot equal 0. Now I'm going to move on to rule 3, multiplying out the denominators. What I mean by that is, look at the left-hand side. To get rid of the x plus 2, I'm going to have to multiply the left-hand side by x plus 2 over 1. What I do to the left-hand side, I have to do to the right-hand side, so that's going to become x plus 6 over 3x multiplied by x plus 2. Before I finish with that though, remember that I've got two different denominators. The same way I multiplied out the x plus 2, I'm going to do to the 3x. That means that my left-hand side will now read 4x times by 3x is equals to x plus 6 times by x plus 2. And notice in this there are no denominators because I've multiplied it out. Rule number 4. Solve as we would a normal equation. Means that 12x squared is equals to x plus 6 times x plus 2. That means that 12x squared will equal x squared plus 8x plus 12. 11x squared minus 8x minus 12 will equal 0. I got it into that format because it is a quadratic equation, and from here I can use the quadratic formula to solve for x. So, not as difficult as it looked initially. I want you to have a go at the following examples. Press pause on your DVD player, and when you return, we'll go through the explanations. The first one I gave you to do, read 3 over x plus 6x is equal to 9. I'm going to start by making each of these over 1. 9 is the same as 9 over 1. 6x is the same as 6x over 1. Now I look at my denominators. My LCD, or my lowest common denominator, is equal to x. Multiply everything by x. So this will be 3 over x multiplied by x over 1 plus 6x over 1 multiplied by x over 1 is equal to 9 over 1 multiplied by x over 1. This is going to give me 3, because the x's will cancel, plus 6x squared is equal to 9x. It's all over 1, so I don't need to put that in. I can leave that out. Take everything across to one side because it's x squared, so that will be 6x squared minus 9x plus 3 is equal to 0. That means that 2x squared minus 3x plus 1 is equal to 0. The reason that became 2 is because I divided everything through by a common 3. This will factor out to become 2x minus 1, x minus 1 is equal to 0. That will give me minus 2x minus x is minus 3x plus 1, 2x squared. So that's fine. That means that 2x minus 1 is equal to 0, or x minus 1 is equal to 0. This means that 2x is equal to 1, means that x is equal to 1 over 2, or x is equal to 1. There's my two answers. X is equal to 1 over 2, or x is equal to 1. Slight problem though. My LCD is x. Now remember that my denominator in any fraction cannot ever equal 0. That means in this case x cannot equal 0. In fact, I would prefer it if you stated that restriction at the start. Do both of these obey that? Yes, they do. That means that these are the two possible x values. The second one I gave you to do, read 2x plus 3 over x plus 1 minus 6 over x is equal to 9. My LCD in this case is equal to, notice that this is over 1, my LCD is x multiplied by x plus 1. That means that x cannot equal 0 and x plus 1 cannot equal 0. That means that x cannot equal negative 1. So my two restrictions are x cannot equal 0 and x cannot equal negative 1. Multiply everything by my LCD over 1. 2x plus 3 over x plus 1 multiplied by that will leave us with 2x plus 3 multiplied by x minus 6 x plus 1 is equal to 9. Let me just write that lower. 9 times x plus 1. What I did here, I did this very fast compared to the previous example. I looked at my denominator and I looked at my LCD. I also looked at what is lacking from my denominator as it stands to make it the LCD. What do I need to multiply this by? What I do to the bottom, I do to the top. That 2x plus 3 will be multiplied by x because I had to multiply x by that. Same thing with that one over there. I had to multiply x by x plus 1. What I do to the bottom, I do to the top. With the 9, the LCD was x plus 1. I had 1, so I had to multiply this by the whole LCD, which is why I got to that. This means that 2x squared plus 3x minus 6x minus 6 is equal to 9x squared plus 9x. Two x squared minus 9x squared is minus 7x squared, plus 3x minus 6x is minus 3x. Minus 3x minus 9x is going to give me minus 12x. Minus 6 is equal to 0. I took it all across because of the x squared. I'm now going to use my quadratic formula because this one here can't be factorized. If I use my quadratic formula, I'm going to say x is equal to minus b plus minus square root of b squared minus 4ac over 2a. That means that x is equal to minus b, which is minus times minus 12, plus minus square root of b squared, which is minus 12 squared, minus 4 a c, all of that divided by 2a, or 2 times negative 7. That's going to equal positive 12 plus or minus square root of 12 squared, which is 144, minus 4ac. Negative times a negative is positive, times a negative is negative. 4 times 7 is 42. 42 multiplied by 6 is going to give me 252. Notice something, 144 minus 252 is going to give a negative answer. That means for this one, there is no solution. Number 3, x plus 6 divided by x minus 4 plus 5 over x squared plus 2x minus 24 is equal to 5 over x plus 6 multiplied by x minus 4. I'm going to start by finding my common denominator. Before I do that though, I'm going to leave this as x plus 6 over x minus 4 plus 5 over. Factorize this. That's going to become x plus 6 multiplied by x minus 4 is equal to 5 over x plus 6 multiplied by x minus 4. That means that for this question here, the LCD is equal to x plus 6 times by x minus 4, which means that x cannot equal negative 6 and x cannot equal positive 4. Keep that in mind. If that's my LCD, this is going to read x plus 6 multiplied by x minus 4. No, that's going to read x plus 6 multiplied by x plus 6. X minus 4 is part of my LCD. I've got to multiply it by x plus 6 in order to get it to a common denominator. Plus 5, that multiplies out, is equal to 5, again that multiplies out. That means that x plus 6 multiplied by x plus 6, which is just x plus 6 squared, is equal to 0. X plus 6 squared is equal to 0. That means that x plus 6 is equal to 0. X is equal to negative 6. Now, look at our LCD and our restrictions. Remember, we said that x cannot equal negative 6. And the answer we got to in this case is that x is equal to negative 6. That means for this one, there is no solution. Number 4. X squared minus 4x over 2 plus 3 over x minus 4 is equal to 3.5. I'm going to start by simplifying my expressions. X squared minus 4x is going to become x minus 4 over 2 plus 3 over x minus 4 is equal to 3.5 is the same as 7 over 2. 2 times 3 is 6 plus 1 is 7 over 2. That means that in this case here, our LCD is equal to 2x minus 4, which means that x cannot equal 0 and x cannot equal positive 4, because that makes our denominator 0, which has no real solution. That's our LCD. It means that this is going to become x multiplied by x minus 4 multiplied by x minus 4 plus 3 multiplied by x minus 4 is equal to 7 times by x minus 4. Number 4, red. X squared minus 4x over 2 plus 3 over x minus 4 is equal to 3.5. I'm going to start by simplifying this. This is going to become x multiplied by x minus 4, take out a common factor of x out there, divided by 2 plus 3 over x minus 4 is equal to 3.5, which is the same as 7 over 2. 2 times 3 is 6 plus 1 is 7. Before I get my LCD here, this one is going to become a little bit nasty because we are going to be multiplying that by that once we've got our LCD, which is going to be a bit difficult. I'm going to use the K method. I'm going to say let K equal x times x minus 4. I'm not changing anything. All I'm doing is, instead of writing that long thing out, I'm just writing k over 2 plus 3 over k is equal to 7 over 2. Why did I do that? Well, again, I'm just writing it out in a simpler form so that when I multiply it by LCD, it becomes a lot easier to find the solution to. My LCD in this case is going to be 2k. That means that k cannot equal 0. That means that x multiplied by x minus 4 cannot equal 0. Means that x cannot equal 0, or x cannot equal positive 4. Not or, and x cannot equal positive 4. This is our restrictions. We now move into it. LCD of 2k, this will have to be multiplied by k to become 2k, which means that what we do to the bottom we do to the top. That's k squared plus 3 times 2. K to 2k goes twice. What we do to the bottom we do to the top is equal to 7k. That means that k squared minus 7k plus 6 is equal to 0. And that can be factorized. This can become k minus 6 multiplied by k minus 1 is equal to 0. That means that k is equal to 6, or k is equal to 1. That's not the end of it. Remember that earlier on I did say k equal to x times x plus x minus 4. So we are going to use that again. K is equal to 6. That means that x multiplied by x minus 4 is equal to 6, or x multiplied by x minus 4 is equal to 1. This means that x squared minus 4x minus 6 is equal to 0. Unfortunately for this one here, I am going to have to use either completing the square or the quadratic formula. And I'm going to find that my x values are going to be either 2 plus root 5 or x is equal to 2 minus root 5. This is after using the formula. For this one here, this is going to become x squared minus 4x minus 1 is equal to 0. Again, unfortunately, I'm going to have to use either the quadratic formula or completing the square. This is going to yield two x values of either x is equal to 2 plus root 10 or x is equal to 2 minus root 10. Now I have not bothered to do the quadratic formula or completing the square for this example here. All I did was go from that to the answers. Obviously you will not be able to do that. I had to use the quadratic formula. I didn't do it on screen because in the previous tutorial that dealt with completing the square and the quadratic formula, I did extensive examples on that. If you are still unfamiliar on how to use the quadratic formula, go back to that tutorial. Number 5, red. 2 over 4x squared minus 1 plus 1 over 1 minus 2x is equal to x over 2x plus 1. Before I find LCD, I'm first going to simplify. This will become 2 over 4x squared minus 1. Isn't this a difference of 2 squares? This will become 2x plus 1 multiplied by 2x minus 1 plus 1 over. Now this is 1 minus 2x. Let's leave it as is for now, but we are going to change that. Is equal to x over 2x plus 1. Problem. That is the same as that. That is similar to that, but not quite the same. Now think about this. 1 minus 2x. What if I multiplied it by a negative 1? That would give me negative 1. Negative 1 times negative 2x is positive 2x. Written differently, that's 2x minus 1. How did I get to that? From that, I multiplied it by negative 1. So what we are going to do, we are going to use a technique called changing the sign. In order to make this 2x minus 1, we are going to multiply it by a negative, so that positive will become negative. Now I can find my LCD. My LCD is going to be given by 2x minus 1 multiplied by 2x plus 1, which means that 2x minus 1 cannot equal 0, 2x cannot equal 1, x cannot equal 1 over 2. Or 2x plus 1 cannot equal 0. That means that 2x cannot equal negative 1, x cannot equal negative 1 over 2. These are our restrictions or our asymptotes. Please keep that in mind. Now, if I multiply that entire expression by the LCD, I'm going to get a result of 2 minus 1 multiplied by 2x plus 1 is equal to x multiplied by 2x minus 1. That means that 2 minus 2x minus 1 is equal to 2x squared minus x. Take the 2x squared across to give you negative 2x squared minus 2x plus x is minus x. 2 minus 1 is plus 1 is equal to 0. Divide through by negative, that means that 2x squared plus x minus 1 is equal to 0. This can factor out to become 2x minus 1 x plus 1 is equal to 0. That means that That means that 2x minus 1 is equal to 0, 2x is equal to 1, x is equal to 1 over 2, or x plus 1 is equal to 0. That means that x is equal to negative 1. Should hold true. One slight problem though. This here. My LCD said that x cannot equal 1 over 2. So for this one, there's no solution. So our only answer is x is equal to negative 1, and that holds true. And that brings us to the end of the 5th algebra tutorial dealing with fractions. The next tutorial is titled Inequalities, and you will notice that the workload is very similar to today's tutorial. Before you move on with it, I want you to please go through the exercise that I left for you in the workbook.